Hello, welcome to a brand new unit. This is Unit 7, and today's video is video number 56, and we're going to review how to compute slope between points. I'm Mr. Miller.
And I'm Ms. Les. Hello.
All right, let's get started. All right, for our first problem, we're going to compute the slope between 2 points in a graph, and then we'll learn how to do it without a graph. So we're going to start by drawing a slope triangle. All right, so we're going to take a vertical step and then a horizontal step. And the vertical step, we went up, so that's positive. So we're going to record the rise. The rise is how much the y-coordinate changes. So since we went up, it changed by 4. And then since we went over, the run is 2. So the vertical change is the rise, the horizontal change is the run. Ms. Les, how do we compute the slope from that?
So rise over run would give us, for the rise, we count the units going vertically. So 1, 2, 3, and 4. So that is 4. And for the run, we went 2 units, 1 and 2.
Yeah, I think everyone saw this last year, but that symbol m comma a b, comma b, or in parentheses a comma b, that just means the slope between a and b.
Yeah, so the variable that we'll be using for slope is m.
And Ms. Les, you simplify it. So we want to remember, simplify the slope. If you need an ABC key on the calculator, that's fine. But always try to simplify the slope.
Yeah, I think these you guys can do now.
Oh yeah, I think so. Okay, let's do C and D. So it's kind of really tough to draw electronically here. So, oh, that's really good.
Okay, so here's my triangle. So again, my vertical distance, or the difference of y's, I have 2 units. And then horizontally, my run is 3 units. But in this case, I'm going down, okay? Or I went down vertically, so my slope will be negative.
Right.
So again, it will be a good idea even before you answer the question to kind of take a look at your line. If it goes down to the right, that tells us our slope will be negative.
Right.
So negative 2 over 3. Again, rise over run.
Okay. Then the last one, this one's tricky. So you went down, so we could say the rise is negative 4, but the run is 0 on that one.
And hopefully remember what happens.
Oh, it blows up. You can't even write that. A math teacher can't even look at that.
We don't know what to do with it. So anything over 0 will be
undefined.
Undefined.
Right, so if you even tried that on a calculator, it would say error, division by 0. So it's not 0, it's just not a number. Vertical lines, if points are located on a vertical line, they don't have a slope. Okay, let's see what's next. So sometimes we're given a figure, and we have to compute the slope, like of the sides. So we're going to compute the slope of the 3 sides of this triangle.
So again, if I'm going from A to B, here is my rise and here is my run. So I'm going 1, 2, 3, 4, 5 units and 2 units to the right. And in this case, again, my line goes down. So I know my slope will be negative.
Right. So we know that whatever we get, if it's kind of going, the side's going down, it's decreasing, negative slope. BC is increasing though, so this one's going to be positive.
So again, do my slope triangle. So my rise in this case is 3 units, and then 2, 4, 6. So rise over run, again, 3 over 6, and that simplifies to 1 over 2.
Okay, one side left.
So here is my rise. Okay, here is my run, so 2 units, and this one is 8 units.
Yeah, I think so.
Yeah,
I was trying
6
to count.
plus 2, here's a shortcut.
Yeah.
So we have 2 over 8, and again we can simplify this one to 1 over 4.
Okay, Ms. Les, we have a little bit of a curveball this time. So this time, we got to be careful because the squares don't always count as 1 unit. So if we notice on this one, along the x-axis, they're going up by 2's. So in the x direction, when we do the run, we have to realize each square counts as 2. And then in the vertical direction, they're going up by 5s. So when we do the rise, we got to remember that each square counts as 5.
Okay, so
I hate it when that happens.
Triangle, yeah,
Okay.
disappeared. So here is my rise, and here is my run. Okay, so when I look at the units, I went from 25 to 35, so that's 10 units. And then horizontally, we go from 2 to 12, so that's 10 units. So
It doesn't look the same, but the scales are different.
So again, I'm going to do my rise over run. So 10 over 10. And because we went down, or the line goes down to the right, your slope will be negative. Okay, so for our last point, I have RS. Again, let's do the slope triangle. So again, if I look at the rise, I go from 5 to 15. So this one again is 10 units.
Yeah.
And I go from 2 to 8, which is 6 units right there.
Okay.
So this one, I'm going up to the right, so my slope will be positive. 10 over 6. And we can simplify this one, and we can simplify this one as well. So let's put this as -1 and 10 over 6.
Very good. Now, we're going to go without a graph. So, just by looking at the coordinates of the points, we can figure out what the rise and run were. So we don't even need a picture, and then the slope. So the rise is just how much y changes. So if we look at the y coordinates, we started with 7 and it went down to 5. It decreased by 2. So the rise is -2. And then the run is how much x changed. It started at 10 and it went up to 16. So that would be 6. And then now our slope would be -2 over 6, which is -1/3. That's pretty cool. We don't even need a picture. So on the next one, look at the y's. So we went from 42 down to 32. The rise would be -10. You could get that by subtracting. 32 minus 42 is -10. And the run is how much we change when we go from 3 to 18. 18 minus 3 is 15. That's how much x changed. And then so the slope would be -10 over 15, which is -2/3. Now, that's the idea behind the formula. So we're ready for our last slide here. This is the famous slope formula down here. And it's really what we were just doing. To get the rise, we subtract the y coordinates. We do the second one minus the first one to find the change. And then to get the run, we subtract the x coordinates.
So let me label these for you. So
Right.
for my first point, I have x1, y1. And for my second point, I have x2 and y2.
Okay.
So to calculate the slope, let's plug into the formula. So m equals 9 minus 6
Yep.
over 4 minus a -3.
Very good. We got to be
Be
careful with
very-
that negative so we don't lose any negatives. So, all right. 3/7. And it doesn't reduce. We're done. Okay.
Okay, so let's label the next set.
So remember the ones indicated came from point 1. The twos indicated they came from point 2. And so y2 minus y1 would be -2 minus 10. And the denominator, 5 minus a -4. Okay, we got this. That'd be -12 over 9. And I believe that'd be -4/3.
Okay, great.
I hope this is bringing back memories. I know they know this. They've
I
seen this
hope so.
before. So this is old news.
Okay, our last set, x1, y1,
But-
x2.
I gotta say, I think we're gonna
Right,
use this
so-
for some things they haven't done yet. So you're gonna see some new stuff this unit. This is just where we're starting. Okay, what do we have this time?
Okay, so plugging into the formula, we have 12 minus 7 over 3 minus 3.
Uh-oh. So that would be 5 in the numerator over 0, which is
Undefined.
Yeah, these points lie, if you graph them, they lie on a vertical line. So again, not 0, it's not a number. 0 is a number, this is undefined.
Yeah, so if you're unsure which one is which, plug it in on a calculator. If you get an error, that tells you it's undefined.
Exactly. Okay, so here's the general assignment. You're probably going to have to pause the video, and you may have to zoom in a little bit so you can see the squares. But just like our example, here's a triangle, and you're going to find the slope of the 3 sides. So a little hint, 2 of them are positive and 1's negative. So you get 2 positive slopes, 1 negative slope. And then for problem number 2, you're going to use the formula, and it's right there. You can use that.
Okay, awesome.
All right, we'll see you next time.
See you. Good luck.